In this session, we'll be discussing about longest remaining time first, which is based on longest burst time, and that too it is having a what? Preemption nature. There may be suspensions of jobs. If burst times of any two jobs are same, then choose the lowest arrival time. If arrival times are also same, then choose the lowest process ID. So it enhances throughput. Advantages is average waiting time and turnaround time is reduced, and there may be a chance of starvation to what? Shorter jobs. So let us see this example. There is arrival time 0. No process is there in ready queue. They have started at arrival time 1. Only one process has come, that is P1. Don't execute completely. One unit we will do. It executed up to next arrival time. Next arrival time of the job is 2 only. So it executed 1 unit of time, balance is 1. At arrival time 2, P1 is carry forwarding, P2 is just dropped. Among these two, which is having a longest burst time? 4. So cut up to next arrival time job, balance is 3. It executed only 1 unit of time, P2 is executed. Now P1, P2, one more process also entered into the ready queue, that is P3. If you see that it needs 6 units of time, cut up to only 1, balance is 5. So P3 is executed for 1 unit of time. P1 is carry forwarding, 2 is carry forwarding, 3 is carry forwarding, 4 also carry forwarding. Among these latest remaining times, which is having highest burst time P4, execute only 1 unit of time. Don't give all, because there are some preemptions. There may be other jobs may be having a longest burst times. So P4 is executed for 1 unit of time. Now let us compare remaining. So P4 needed 7 and the rest is needed 5, 3 and 1. So P4 is given one more time, balance is 6. And P4 will be given one more time chance because it is the longest burst time. So balance is 5. Now P4 needed 5, P3 also needed 5, P2 needed 3 and P1 needed 1. So we want to give preference to P3 and P4. There is a conflict. So you want to resolve the conflict, choose the lowest process ID. So because this guy needed 5 and this guy is also needed 5, so P3 will be executed for 1 unit of time. So P3 balance needed 4. Now 1, 3, 4, 5. So P4 has got highest burst time. This one I am looking 1, 3, 4, 5. So P4 is executed one more unit of time. It needed 4. 4, 4, 3, 1. Two burst times are same, so we will give a chance to P3. P3 is executed for 1 unit of time. Balance is 3. So next time P4 will be given a chance. It executed for 1 unit of time, 11. And its balance is 3. Now you observe 3 3s are there. 3, 3, 3. So whenever burst times are same, we need to take the lowest process ID. This time P2 will be given a preference, 1 unit of time. Balance is 2. Next time this is needed 3, this is needed 3. P3 will be given a chance, 1 unit of time. Balance is 2. Next time only one process is there, that is a P4, which is having the highest burst time. So it is executed and balance is 2. Next 2, 2, 2. Again P2 will be given a chance. This needed 1. Next 2, 2. P3 will be given a chance. P3 will be given a chance. It executed 1 unit of time. Balance is 1. Then 211. P4 will be given a chance. It executed 1 unit of time. Then all ones. See the magic of LRTF. So whenever burst times are same, take the lowest process ID, P1. So it is completely executed by 18. Then after the 3 ones, P2 will be given a chance. It is also given a 1 unit of time. It completely executed at 19. Then after that P3, it completed at 20. Then P4, it completed at 20. So this is how to do LRTF. So this is completed at 18, this is completed at 19, this is completed at 20, this is completed at 21. So let us take turnaround time. So CT minus arrival time, 18 minus 1, then 19 minus 2, then 20 minus 3, then 21 minus 4. So 17, 17, 17, 17. Waiting time, 17 minus burst time, 17 minus burst time, 17 minus burst time, 17 minus burst time. So this is how to solve longest remaining time first CPU scheduling algorithm.